it's late. Or maybe it's the middle of the night. Or maybe you're listening to this in the quiet hours before dawn, your eyes already heavy, your body already halfway gone from the day. The room is dark, or dim, or lit only by the small soft glow of whatever screen you fell asleep near. Outside, the world has slowed down to almost nothing. Tell me, where are you right now? What time does the clock say where you are? Are you in a city that hums even in the dark, or somewhere so quiet you can hear the trees? Are you under thick blankets while winter presses against the glass, or stretched out in the heat of a summer night, a fan turning slowly somewhere nearby? Whatever the answer, you are here, and this question is for you. Have you ever looked up at the night sky and felt it? Not just seen it, but felt it. That strange pull, that sensation of standing at the edge of something too large to hold. Billions of stars scattered across the dark, galaxies folded inside galaxies, an entire universe that has been expanding since before our planet existed, growing outward in every direction, right now, while you breathe. And yet, nobody has arrived, no ship has landed, no signal has come through that we can decode with certainty. No visitor has knocked on the door of our small blue world. Why? Most people assume the answer is one of two things. Either we are alone, and there is nobody to come, or we simply haven't been found yet, and someday they will arrive. But the real answer is stranger than either of those. Larger, more unsettling, and in a strange way, more beautiful. The real answer is the speed of light. That thing everyone tells you is fast, the ultimate speed limit of the universe, the ceiling that cannot be broken, the rule that sits at the foundation of everything we know about how reality works. Here is what almost nobody stops to say out loud. It is not fast enough, not even close to fast enough, when measured against the true size of what is out there. And tonight, in this soft space between the day you finished and the sleep that is coming for you, we're going to sit with that together, slowly, carefully, one idea at a time, with nowhere to rush. Let your mind open. Let the edges of things soften the way they do when you're almost asleep. Let the ceiling of the room above you become the sky. Breathe. We're just beginning. Light travels at 300,000 kilometers per second. Let's say that again, because the number deserves to be heard properly. 300,000 kilometers in one single second. Try to feel it rather than just repeat it. In the time it takes you to blink, light could travel from where you're lying right now all the way around the circumference of the Earth, 7.5 times, not once, not twice. 7.5 full laps around the entire planet, before your eyelids even meet. This is a number the human mind is not built to truly hold. We can say it, we can write it down, we can do the mathematics, but we cannot feel it the way we feel the distance to the kitchen, or the length of a drive we've made before. It lives outside the range of what our bodies were designed to understand. So let's begin with something closer. Something our minds can almost touch. From the sun to the earth, light takes about 8 minutes. 8 minutes, not 8 hours, not 8 days, not 8 years. 8 minutes, travelling at 300,000 kilometres every second of that time. Now think about what that means. If our sun went completely dark right now, at this exact moment, you would not know for another 8 minutes. You would keep breathing. Keep thinking, keep existing under a star that was already gone, warmed by light that was already a memory, a ghost of something that had ended while you were still living as if it hadn't. There is something quietly disorienting about that. The world as it appears is always slightly behind the world as it is. Now move further out. The nearest star to our own solar system is called Proxima Centauri. It sits just over 4 light years away from us. A light year, if the word is new to you, is the distance that light covers in a full year. 365 days of travelling at 300,000 kilometres per second, without ever slowing, without ever pausing, without ever arriving at anything in between. That is 1 light year, and Proxima Centauri is 4 of those away, which means that even if you could somehow travel at the speed of light, even if you could become light itself, it would still take 4 full years to reach the closest star. Not a long weekend, not a semester abroad, 4 years of travelling at the maximum speed the universe permits, and you would arrive at the nearest neighbour. That is the closest star. That is the first step, and already the numbers have left the comfortable world behind. Now let the scale keep expanding because we have barely started. Our galaxy, the Milky Way, stretches approximately 100,000 light-years from one side to the other. Picture that for a moment not as a number but as a shape, a flat spiral of stars, gas, dust, and darkness, so wide that light itself, crossing it from edge to edge without stopping, would take 100,000 years to make the journey. During those 100,000 years, every civilization that has ever existed on Earth would rise and fall. Every language ever spoken would be born and forgotten. The land masses of our planet would shift. The species that walk its surface would change. Everything we consider permanent and ancient would come and go, dozens of times, before the light reached the other side, and the Milky Way is just our galaxy, just one among roughly 200 billion observable galaxies in the universe, not 200 million. 200 billion, the observable universe, the sphere of space from which light has had enough time to reach us since the Big Bang, stretches about 93 billion light-years in diameter. 93 billion. The words stop carrying weight at that scale. They become sound, rhythm, approximation. Breathe. You don't need to understand this the way you understand a map. You just need to let it sit inside you for a moment, the way something very cold sits in your hands before the feeling comes, the light reaching your eyes from the most distant objects left on its journey before this planet existed, before the sun had ignited, before the atoms that now make up your body had been assembled inside any star at all. That ancient light, launched billions of years before you, arrived here in your lifetime, in this era, perhaps in this very night. Every time you look at the sky, you're looking into a past that stretches further than the mind can follow. The stars you see are not where they appear to be. The light showing them to you is old. Some of those stars no longer exist. They burned out years ago, or centuries ago, or millions of years ago, and the news just hasn't arrived yet. We're reading a book written in a language of light, and every page is from a different century, and all of this extraordinary depth and age and distance is shaped and limited by that one number, that speed, 300,000 kilometers per second, which is beginning, slowly, to feel less like a limit and more like a wall. So let's come back to the question that brought us here tonight. Why haven't aliens ever reached Earth? Why, in a universe this old, this large, this full of stars and planets, has nothing from somewhere else ever arrived on our doorstep? The simple version of the answer is this. The distances are not just large, they are functionally incomprehensible in terms of what any physical object would need in order to cross them. Even the nearest star, Proxima Centauri, 4 light-years away, would take our fastest current spacecraft tens of thousands of years to reach, and Proxima is essentially next door on the scale of the galaxy. But there is a deeper layer to the answer, and it matters more than the distance alone. The speed of light is not simply a practical barrier, something that better engineering might one day overcome. It is a physical law, a fundamental feature of how the universe is structured. The laws of physics as we understand them say this: no object that has mass can reach the speed of light. Not ever. Not with more fuel, not with better engines, not with any technology yet imagined. Here is why. The closer an object with mass gets to the speed of light, the more energy it requires to keep accelerating. Not just more energy, but exponentially more. As the speed approaches 300,000 kilometers per second, the energy required approaches infinity. To actually reach the speed of light, you would need an infinite amount of energy to apply to a finite object. Infinite energy does not exist. The universe does not offer it. This means that even a civilization 1,000,000 years more advanced than ours, a civilization that has mastered fusion, that has built structures around stars, that has solved problems we haven't yet learned to ask, would still face this wall. Not because they weren't clever enough, because the wall is not made of technology, it is made of physics. This is the key thing to sit with tonight. We are not talking about a limitation that will be engineered away in a few centuries. We are talking about a rule that appears to be woven into the structure of reality itself. Appears to be. That word matters. Because the universe, as we'll see, has a few folds and corners that even our best current understanding has not fully mapped. There may be ways around the wall that the wall itself does not forbid. But for now, let this settle. Let it sink slowly, the way deep things sink, without hurry, without noise. There are ways people have imagined getting around the problem, and some of them are not as fictional as they sound. In science fiction, we know the shorthand well. Wormholes, warp drives, hyperspace. The captain gives the order, the stars streak past the windows, and in moments the ship reappears somewhere else entirely. Light years crossed in a breath. It makes for beautiful storytelling. But the interesting thing is that these ideas did not begin with storytellers. They began with physicists. In 1935, Albert Einstein and his colleague Nathan Rosen were working through the mathematics of general relativity, the theory that describes how mass curves space and time. What they found, buried in the equations, was something unexpected. The mathematics seemed to allow for bridges, tunnels through the fabric of space-time itself, passages connecting two distant points, not by crossing the space between them, but by folding that space so the 2 points touch. We call these Einstein-Rosen bridges today. Most people know them by the name wormholes. The concept is elegant in the way that genuinely strange ideas sometimes are. Instead of travelling across the distance, you eliminate the distance. You take 2 points in space that are separated by millions of light years and, through some radical manipulation of gravity and geometry, you bring them together. Then you step through the middle. You would not be travelling faster than light. You would be travelling through less space, like folding a piece of paper until 2 points on opposite sides are touching, and then poking a pin through both at once, rather than walking the full length of the page. The problem, and there is always a problem, is that the mathematics which permits wormholes also demand something that we have never observed and may not be able to create. Something called exotic matter, a theoretical substance with negative energy density, which would be required to hold the throat of the wormhole open long enough for anything to pass through. Without exotic matter, any wormhole would collapse the instant it formed. The geometry would snap back. The tunnel would seal before you could take a step. Whether exotic matter exists, whether it could be produced in useful quantities, whether the wormhole could be stabilized and made safe, none of these questions have answers yet. But the mathematics does not say it is impossible, and in the silence of this night, there is something strangely comforting about that. Somewhere, perhaps, someone has already worked it out, sitting beneath an unfamiliar sky, patient, brilliant, finding the path that the equations were always hiding in plain sight. There is a second idea, different from wormholes, and in some ways even more poetic in its strangeness. It comes from a physicist named Miguel Alcubierre, who published a paper in 1994 that proposed something genuinely unusual. Not a tunnel through space, and not travelling faster than light in the conventional sense. Something else entirely. His idea was this: do not move the ship through space. Instead, move the space around the ship. To understand what this means, imagine space not as empty nothing, but as a fabric, a surface that can be stretched and compressed, pushed and pulled by the presence of mass and energy. This is not a metaphor, by the way. This is what general relativity describes. Space really does curve and flex in response to matter. Alcubierre's proposal was to engineer a specific kind of distortion. You would compress the space in front of the ship, drawing your destination closer, and simultaneously, you would expand the space behind the ship, pushing your origin further away. The ship would sit inside a bubble of undistorted space-time, perfectly still relative to its immediate surroundings, while the bubble itself was carried forward by the distortion. From the ship's perspective, nothing would be violating the speed of a light. Locally, the ship would not be moving fast at all. But from the perspective of a distant observer, the ship would cross enormous distances in a fraction of the time light could manage. It would not be breaking the laws of physics. It would be bending them so creatively that the laws themselves would barely recognize what was happening. When Alcubierre published his paper, the physics community took it seriously as a mathematical construction, while noting the enormous practical obstacles. The energy requirements he calculated were staggering, roughly equivalent to converting the entire mass of Jupiter into negative energy, which, as things currently stand, is not something on any agency's roadmap. But here is what matters. Subsequent physicists have worked on refining the geometry, and some versions of the drive require far less exotic energy than the original calculation. Not practical, but reduced. Moving in a direction. The equation exists. The mathematics says this is not forbidden. In a universe where what is mathematically permitted tends, eventually, to exist somewhere, that is worth something. Perhaps right now, in some corner of the cosmos we cannot see, something is moving through a ripple in the geometry of space, crossing distances we could not cross, going somewhere we cannot imagine, quietly, without violating a single rule. There is a paradox that has quietly unsettled physicists, astronomers, and philosophers for more than 70 years. It did not come from a long paper or a complex experiment. It came from a lunch. In the summer of 1950, a group of physicists at Los Alamos were walking to the dining hall together. The conversation had turned to a cartoon in a New York newspaper about flying saucers. They were joking, speculating, being casual about it the way scientists sometimes are when they're not officially working. And then Enrico Fermi, one of the greatest physicists of the 20th century, the man who had built the first nuclear reactor, who understood the deep structure of matter better than almost anyone alive, said something simple and devastating. But where is everybody? He was asking about extraterrestrial civilizations, and the question, which sounded almost like a joke, turned out to be one of the most durable problems in science. Here is why it bites so hard. The universe is approximately 13.8 billion years old. Our galaxy alone contains somewhere between 100 and 400 billion stars. A significant fraction of those stars have planets. Many of those planets orbit within the habitable zones of their stars, where liquid water could exist. By even the most conservative estimates, the conditions for life should have arisen somewhere other than Earth. And if life arose, some of it may have become complex. Some of that complexity may have produced intelligence. Some of that intelligence may have built technology, and if any of that happened even 1 million years before it happened on Earth, those civilizations would have had extraordinary time to expand, to send probes, to colonize, to communicate. 1 million years is nothing on the cosmic timescale. A sufficiently motivated civilization, expanding at just 1% of the speed of light, could still reach every star in the Milky Way within a few million years. And yet, silence. We have been scanning the sky with increasingly sensitive instruments for decades. No unambiguous signal, no megastructure around a distant star, no probe parked in our solar system waiting to be noticed, no pattern in the noise that resolves into a message. The Fermi paradox does not prove we are alone. It only says that the universe is much quieter than we might have expected, and that something, somewhere in the chain from chemistry to civilization to contact, is filtering most of the story out. We do not know where that filter is. That uncertainty is the part that keeps the question alive. Let's leave the abstract for a moment and enter something more narrative, a small piece of fiction grounded in real physics, to give the ideas a shape you can hold. Imagine a civilization. Give them a name, the Builders. They live on a planet orbiting a star in the constellation Cygnus, roughly 1,200 light-years from Earth. Their sun is slightly cooler than ours, slightly older, and it has been stable for longer than our solar system has existed. The Builders are intelligent in ways we would recognize, and in ways we would not. They discovered mathematics independently, arrived at the same constants, worked through the same equations. They understand that the speed of light is a hard limit. They know, with the precision of a civilization that has been doing physics for 50,000 years, that no physical object can cross 1,200 light-years in any time frame that would matter to the beings that sent it. But they are patient, and they are lonely in the way that intelligence tends to be lonely, reaching outward, looking for something to reach back. So they build transmitters, vast arrays of antennae pointing at stars they have identified as candidates, stars with rocky planets in habitable zones, with atmospheric signatures that could suggest biology. They encode their signals mathematically, because mathematics is the one language that does not require a shared history to decode. Prime numbers, geometric ratios, patterns that nature does not produce by accident. Those signals left 1,200 years ago. When they departed, we were in the middle of the medieval period. There were no telescopes. There was no concept of what a radio wave even was. We could not have received that signal, could not have recognized it, could not have known to look. Those signals are traveling now, at this moment, at the speed of light, closing the gap that remains. Perhaps they will arrive in a few hundred years, when we have instruments sensitive enough to catch them. Perhaps they arrived last year and are sitting in a data set that no one has yet fully analyzed. Or perhaps the Builders are gone. Perhaps something happened to them 300 years after they sent the signal. Something they did not survive. And what is crossing the galaxy now is the last breath of something that no longer exists. An echo without a source. A voice still speaking after the throat has gone silent. This is one of the hidden sorrows folded into the speed of light. Not only does it prevent travel, it prevents knowing. 1,200 light-years sounds very far, and it is very far in human terms. But set it against the actual scale of things, and it is barely a murmur. Consider the Andromeda galaxy. On a clear autumn night, away from city lights, you can see it with your naked eye. It appears as a faint smudge of pale light, low on the horizon, soft and diffuse, easy to overlook. It is the most distant object that human eyes can see without any instrument at all. The light you're seeing when you look at Andromeda left that galaxy approximately 2.5 million years ago. 2.5 million years. When that light began its journey toward you, The genus Homo had just barely appeared on Earth. Our ancestors were small-brained, tool-using primates walking the grasslands of Africa. They had no language, no fire, no shelter more complex than what the landscape provided. They had no awareness that the universe contained anything beyond what their eyes could see and their hands could touch. And the light that departed from Andromeda before those creatures existed, before your evolutionary lineage had taken the shape it would take, before the ground had been broken for a single monument that still stands, that light crossed 2.5 million years of empty space and arrived at your retina. Tonight, in this life, in this moment. This is what it means to look at the universe. Every glance upward is a journey backward through time to a depth that makes all of human history feel like a single afternoon. The stars you see are not the stars as they are. They are the stars as they were, years or centuries or millennia ago. Some of those stars are already gone. Their light is still travelling, still arriving, still illuminating, but the source has collapsed or exploded or faded. We are receiving a broadcast from something that may no longer exist, and Andromeda itself is moving toward us, slowly, on the timescale of galaxies, but consistently. In roughly 4 billion years, it will merge with the Milky Way. The two galaxies will interpenetrate, their stars and gas and dark matter mixing over hundreds of millions of years. The night sky of any world that survives the merger will be unrecognizable, dense with new light, new nebulae, new geometry, a new sky for beings that will be nothing like us, looking out at a cosmos that will remember nothing of this night. Let's bring the scale back down to something we actually built and launched, because there is something grounding about the specific and the real. Voyager 1 is a spacecraft about the size of a small car, launched by NASA in September of 1977. It weighed just under 1,000 kilograms at launch. It carried instruments to study the outer planets, a camera system, a magnetometer, and a gold-plated copper record containing sounds and images from Earth, a kind of message in a bottle thrown into the deepest ocean that has ever existed. Voyager 1 is still operating. Right now, as you listen to this, it is transmitting data back to Earth from a distance of more than 22 billion kilometers, traveling at roughly 60,000 kilometers per hour, still moving outward, still alive after more than 4 decades of flight. 60,000 kilometers per hour sounds extraordinary, and it is, by every scale that applies to human experience. It is faster than anything else we have ever sustained over any meaningful distance. But it is approximately 0.0017% of the speed of light. At that speed, to reach Proxima Centauri, the nearest star beyond our Sun, Voyager would need approximately 73,000 years. Not 7,000, not 700, 73,000 years. There will be no one to receive it when it arrives. No civilization that calls itself human, with any continuity to the one that launched it, will still exist in any recognizable form. The agency that built it will be as remote in history by then as the people who built Stonehenge are to us now, and further. The spacecraft will drift past Proxima, with no one watching and nothing to detect it, and continue into deeper darkness. And yet we sent it, we built it, with the full knowledge that it would outlast everything we know, and that no human eye would ever see where it ended up. And we launched it anyway. We packed a record full of music and mathematics and the sound of wind and ocean waves, and we attached it to a machine we knew would drift forever, and we let it go. That act, I think, says something true about what we are, something worth knowing. Before you fall asleep tonight, let that sit with you, the gesture of it, the quiet audacity of creatures who cannot cross the dark, reaching out into it anyway. If travelling to the stars is beyond us, at least for now, the question becomes whether we might listen, whether the darkness, which refuses to let us cross it, might still carry something worth hearing. This is the logic that gave rise to SETI, the search for extraterrestrial intelligence. Beginning in the 1960s and continuing in various forms to this day, researchers have used radio telescopes and other instruments to scan the sky for signals that could not have been produced by natural processes. The assumption is simple. If an intelligent civilization exists somewhere in our galaxy, and if they are transmitting, and if any part of that transmission is directed toward our region of space, and if we are listening at the right frequency at the right time, we might hear them. That is a lot of conditions to meet simultaneously. But the universe is old and large, and we've been patient, and once, for 72 seconds, something happened. It was August of 1977. A researcher named Jerry Eman was reviewing data from the Big Ear radio telescope at Ohio State University. Going through printouts of radio signals the telescope had recorded while pointed at a region near the constellation Sagittarius. Most of what he saw was noise, the ordinary static of the universe, hydrogen clouds and background radiation, and the indifferent hiss of empty space. And then he found something different, a signal of remarkable intensity, at a frequency consistent with the emission of neutral hydrogen. One of the frequencies considered most likely to be used for interstellar communication. It lasted the full 72 seconds that the telescope's field of view took to sweep past the source. It was unlike anything around it. Eamon circled it on the printout and wrote one word in the margin. Wow! The signal was never detected again. Repeated observations of the same region of sky found nothing. No follow-up instrument confirmed it. Decades of analysis have not produced a definitive explanation. Though some researchers have proposed a comet or other natural source, it may have been something extraordinary. It may have been something mundane that produced an unusual pattern. We do not know. What we know is that for 72 seconds, the sky offered something, and then closed back up and left us holding a question with no answer. That is the texture of this search. Vast patience, occasional wonder, and a silence that is never quite final enough to stop the listening. You're near your own kind of silence now. Let it be the same way, not empty, just waiting. There is a phenomenon in quantum physics that sits at the edge of what our intuitions can handle, and it has implications that physicists are still working through decades after it was confirmed. It is called quantum entanglement. Here is the basic picture, as clearly as it can be drawn. Under certain conditions, two particles can be created in a shared quantum state, meaning the properties of each are not determined independently, but are correlated in a way that persists no matter how far apart the particles are separated. This shared state is what physicists call entanglement. Now separate those two particles, send one to a laboratory across the city, or across the country, or in thought experiments across the galaxy, then measure one of them. The instant you make that measurement, the other particle snaps into a complementary state. Not eventually, not after a delay, instantly. Einstein found this result so troubling that he refused to accept it, even after the mathematics of quantum mechanics consistently predicted it. He called it spooky action at a distance and argued that the theory must be incomplete, that there must be hidden variables we weren't accounting for, that the universe couldn't actually work this way. But experiments have confirmed it repeatedly, across decades and increasing distances, using increasingly rigorous methods. The correlations between entangled particles are real. They appear to be instantaneous, and they cannot be explained by any signal travelling between the particles, because the effect is faster than light. This seems like it should violate relativity, which says nothing travels faster than light. But the loophole is subtle and precise. You cannot use entanglement to send information faster than light. When you measure your particle, you get a random outcome. You have no control over which result you get, and therefore no ability to encode a deliberate message. The correlation is real, but it carries no choosable content from one location to another. The universe appears to have built a genuine instantaneous connection between entangled particles, and simultaneously ensured that this connection cannot be exploited as a communication channel, as if it threaded the needle of a very specific kind of impossibility. What this tells us about the deeper structure of reality, about whether space is truly the fundamental thing, about whether locality is an illusion at some level. Physicists are still working out. The questions are open. The answers, when they come, may reshape everything. In the meantime, there is something quietly reassuring about knowing that the universe is more connected than it appears. Let's change perspective entirely for a few minutes. Let's try to imagine not what it would be like for us to find someone else, but what it would be like for someone else to find us. Place yourself somewhere other than Earth, a planet orbiting a star of the right temperature and the right age, in the right zone for liquid water, circling a sun about 300 light-years from here. You're intelligent, the way we are intelligent, and probably in ways we're not. You have curiosity, and you have instruments, and you have turned those instruments toward the sky with the same mixture of hope and uncertainty that drives our own searches. Your telescopes are powerful, more powerful than ours, because your civilization has been doing this longer. When you analyze the light of distant stars, you do not just see brightness. You decompose the spectrum, looking for the chemical fingerprints of atmospheres. You know what a lifeless rock smells like in starlight. You know what an oxygen-nitrogen atmosphere looks like from thousands of light-years away. And then, one day, you find something, a star about 300 light-years away, a small rocky planet in the habitable zone, in the atmospheric signature, something extraordinary. Oxygen, methane, and water vapor, all present simultaneously, in quantities and ratios that natural chemistry could not sustain. The only way to maintain that balance is biological activity. Something alive is producing those gases continuously. You do not know if that life is complex. You do not know if there are cities or music or mathematics on that world. You know only that something is breathing. But it is enough. You send a signal. You encode it carefully, mathematically, in patterns that any mind capable of building a receiver should be able to parse. And the signal leaves your world at the speed of light, aimed at that small bright dot 300 years of travel away. 300 years later, it arrives here. But 300 years ago, did we have instruments sensitive enough to receive it? Did we know what to listen for? Did we even know the concept of a radio wave? We did not. And now, if we sent a reply today, they would not receive our answer for another 300 years. 6 centuries of conversation, simply to say hello and learn that hello was heard. Somewhere, that conversation might already be in progress. Your grandparents were alive when one side of it was sent. There is a dimension of the speed of light that we have not yet named directly, but which runs underneath everything we have been talking about. It is the way that light does not only limit travel, but limits knowledge itself. The way the universe shows us only its past, never its present. Think about what you actually see when you look at the night sky. Not what you imagine you see, but what the light arriving at your eyes is actually showing you. The nearest star, Proxima Centauri, you see as it was 4 years ago. Its light has been travelling since then. If something catastrophic happened to it last year, you will not know for another 3 years. You're watching a 4-year-old recording. Now look at a star like Betelgeuse, the bright reddish star that forms the left shoulder of Orion. Betelgeuse is a red supergiant, one of the largest stars visible to the naked eye, and it is in the late stages of its life. Astronomers have known for decades that it will eventually explode in a supernova, becoming briefly one of the brightest objects in our sky, visible even in daylight, leaving behind a neutron star or possibly a black hole. Betelgeuse is approximately 700 light-years away. The light we see from it tonight left that star around the time of the Black Death, while the Aztec Empire was still forming, while Genghis Khan's descendants were still ruling large portions of Asia. Betelgeuse may already have exploded. The explosion may have happened 50 years ago, or 100 years ago, or 200. The shockwave may already be racing through the surrounding gas. The neutron star may already be spinning in the wreckage, and we will not know for centuries because the light carrying that news has not arrived yet. Every clear night, we look at Orion, and perhaps we are looking at a constellation that has already changed, at a star already gone, at a brightness that exists only in transit, already launched, not yet arrived. There is something deeply strange about this. Once you really let it in, the universe does not show us what is. It shows us what was. The sky is an archive, not a window, a gallery of old light, reaching us across gaps of time that make the whole of human civilization look like a single sleepless night. Your thoughts are stretching longer now, less sequential, more like light itself, travelling in a direction, slowing as the distances between thoughts grow. We have been talking about distance and time and the limits of light. But there is a concept that brings all of this together into something more personal, more immediate, and more quietly frightening. It is called the Great Filter. It was proposed in 1998 by an economist and philosopher named Robin Hanson, and it starts from the same place as the Fermi paradox. The universe is old, large, and full of apparently suitable environments for life, and yet we see no evidence of anyone else. Hanson's framework asks, where, in the long chain from simple chemistry to an interstellar civilization, is the step that almost nothing gets through? Somewhere in that sequence, something filters out nearly every potential civilization. Either the filter has already happened, and we are among the rare survivors who made it past, or the filter is ahead of us, and we have not yet faced it. This distinction matters enormously. If the great filter is behind us, then the good news is that we are exceptional. Perhaps the origin of life itself was the near impossible event, the step that almost no planet manages. Perhaps the development of eukaryotic cells, or of multicellular life, or of complex intelligence, or of language and technology, was the filter, something that happened here against all probability. We are the lottery winners of evolution. But if the great filter is ahead of us, then what lies before us is a challenge that has ended nearly every story like ours that has ever been written. Perhaps every civilization that reaches our level of technology proceeds to develop weapons capable of ending it. Perhaps every intelligent species eventually creates something it cannot control. Perhaps there is something about the path from our kind of civilization to an interstellar one that almost no one survives. The most unsettling interpretation of the Fermi paradox is this: if we were to find simple microbial life on Mars, or on Europa, or on any other nearby body, that would actually be terrible news, because it would mean that life is not the filter. Life arises commonly, and therefore the filter must be ahead, still waiting for us. The silence of the galaxy might be the sound of a warning that takes too long to hear, but knowing this, truly sitting with it rather than turning away from it, is also the beginning of choosing differently, of building rather than breaking, of reaching outward rather than consuming inward, of being worthy of being found. Let's bring this back to something hopeful, because the night should not end only in the weight of unsolvable problems. There is real progress being made, and some of it is closer to extraordinary than it appears. Even without violating physics, even without wormholes or warp geometry, there are concepts for reaching meaningful fractions of the speed of light. Not one day in the vague future, but in development now, by teams of serious people with real funding and real mathematics behind them. The most promising of these is the concept of the light sail, sometimes called a solar sail or a laser sail, depending on the specific design. The principle is elegant. Take a sheet of material thin enough that light itself exerts a measurable pressure on it. Not an approximation, not a metaphor. Light does exert pressure. Photons carry momentum, and when they hit a reflective surface, they push. Spread that surface large enough, and the push becomes significant. Now imagine not just sunlight, but a powerful laser array, focused from Earth or from orbit, directed at a tiny spacecraft with an enormous sail. The photons hit the sail, reflect off, push the craft forward. There is no fuel to carry, there is no combustion, there is just light, doing what light does, and a craft that is light enough to respond. The Breakthrough Starshot Initiative, announced in 2016 and backed by serious scientific and financial resources, proposes to send gram-scale probes, essentially circuit boards the size of a postage stamp attached to a meter-wide sail, to Proxima Centauri at approximately 20% of the speed of light. At 20% of the speed of light, the journey takes roughly 20 years, not 70,000 years, 20. The probes would carry cameras and basic sensors. They would fly through the Proxima system, taking photographs, measuring magnetic fields, analyzing what they find, and then they would transmit their data back to Earth at the speed of light, arriving here roughly 4 years after the flyby. 24 years from a decision to launch. We could have photographs of whatever orbits Proxima Centauri. A child born today could see those photographs before finishing their education. The first images of another solar system, taken from within it. Not imagined, taken. The universe is still large, but we are beginning, slowly, to reach. There is one more possible explanation for the silence, and it is the one that I find myself returning to most often in the kind of quiet that a late night produces. Maybe they are here, not in the sensational sense, not in the sense of lights in the sky that resist explanation, in a more precise, more interesting, more unsettling sense. A civilization advanced enough to cross the distance between stars would also, almost certainly, be advanced enough to observe without being observed. The technologies we develop tend to develop together, and a species that has solved interstellar travel has presumably also solved the problem of remaining undetected if it chooses to be. There is a hypothesis in the SETI literature called the zoo hypothesis. It was proposed in 1973 by the astrophysicist John Ball, and it goes like this. The reason we have not detected other civilizations, and the reason none have made contact, is not because they don't exist, and not because they can't reach us. It is because they have chosen not to. They know we are here. Perhaps they have known for a long time, but there is a protocol, an agreement, a shared ethic among the civilizations that have been out in the galaxy long enough to develop one, not to interfere with younger species until those species reach some threshold of development or invitation. In this scenario, we are the animals in the preserve, the ones who don't know they're being observed, the ones whose behavior is being studied with the careful respect of those who understand what disruption would do to a developing intelligence. The silence is not absence. The silence is patience. There is something profoundly humbling about this possibility. Not threatening, exactly. More like being a child in a house full of adults who are carefully waiting for you to be ready for the conversation. We may be passing a test right now without knowing the criteria. Every choice we make about how we treat each other, about whether we build or destroy, about whether we reach toward the sky or close the door on it, may be part of an assessment we never consented to enter. Or none of this is true, and the silence is simply what it seems to be. A very large universe, very sparse, where the distances between intelligent minds have so far been too vast for anything to cross. Both possibilities are available tonight. Both deserve to be held. Here is something that the history of science has taught us, and that I think matters enormously when we try to talk honestly about what we do and do not know. Every generation of scientists has believed, at least in its more confident moments, that it had arrived at a nearly complete picture of the universe, that the fundamental structures had been identified, the major questions answered, and only details remained to be filled in. Every generation has been wrong in exactly that belief. In 1900, the physicist Lord Kelvin made a famous statement to the effect that physics was essentially finished. The laws of motion were understood, thermodynamics was established, electricity and magnetism had been unified. The remaining puzzles were small. They would be resolved soon. 5 years later, Einstein published Special Relativity, which showed that space and time were not what Newton had thought they were, that mass and energy were the same thing, and that the speed of light was a fundamental constant that reshaped the geometry of the universe. 20 years after that, quantum mechanics arrived and showed that at the smallest scales, matter does not behave like anything that macroscopic experience had ever suggested. Particles tunnel through walls. Properties do not have definite values until they are measured. The universe at the quantum level is genuinely strange in ways that are not resolved by getting used to them. And today, our two greatest theories, general relativity and quantum mechanics, are mathematically inconsistent. They cannot both be fully right, and we know it. A theory of quantum gravity, which would reconcile them, remains one of the deepest unsolved problems in physics. On top of that, dark matter, which makes up approximately 27% of the universe by mass, has been inferred from its gravitational effects but never directly detected. Dark energy, which makes up approximately 68% of the universe and is responsible for the accelerating expansion of space, is described by a term in Einstein's equations but not understood in any physical sense. 95% of the universe is made of things we can observe effects of but cannot yet explain. In that context, the statement that faster-than-light travel is permanently impossible carries a certain humility problem. We may be right. The laws as we know them do appear to forbid it firmly, but we're also a species that has been permanently wrong about the completeness of its knowledge every single time it believed itself complete. There is a shift that happens at this point in the night, if you let it. The mind has been holding large things. It has been reaching outward, measuring, counting, imagining, and somewhere in that process of reaching, the effort of it, the sustained concentration, something loosens. The ideas stop requiring active grip. They begin to float. This is not confusion. It is a different kind of understanding, less precise, more distributed, the kind that comes when the analytical layer steps back and something older and quieter takes over. We have gone a long way tonight. We have been to the edges of the observable universe and back. We have looked at galaxies that no human eye should be able to see, measured distances that no human mind was built to comprehend, touched on questions that have no current answers. And now we are here, in this room, in this body, in this particular moment of a life being lived on a small planet in an unremarkable part of a galaxy that is itself unremarkable among 200 billion others. No human being has ever left the solar system. The furthest any person has ever travelled from Earth was the crew of Apollo 13, who swung around the moon at a maximum distance of about 400,000 kilometres. That sounds like a lot, until you remember that Proxima Centauri is 40 trillion kilometres away. In terms of the broader cosmos, no human has moved at all, and yet we are the only beings we know of who have ever looked at the cosmos and thought, I want to understand this, who have built instruments to extend their senses across billions of light years, who have developed mathematics precise enough to describe events that happened before the Earth existed, who have sent a physical object into interstellar space carrying a record of music and voices, on the vanishingly small chance that something, somewhere, might someday find it. The universe looks at itself through human eyes. Every telescope we build is the cosmos developing a new way to see its own edges. Every question we ask is matter wondering what it is. You are that wondering, right now, in this night, in this body that is already beginning to let go of the day. The sky is not empty. You're not small. You're the universe doing the only thing it has ever found itself able to do, noticing. Let the thinking slow now. There is no urgency left in what remains. Choose a star, any star, from the 250 billion or so in the Milky Way. Not a famous one, not Betelgeuse or Vega or Sirius, just one, unremarkable, somewhere in the middle of a spiral arm, the kind that wouldn't make any list of notable objects. A star so ordinary that it has a catalogue number but no name. That star, with high probability, has at least one planet. That planet, with some probability we cannot yet quantify, has conditions compatible with liquid water. In that liquid water, with a probability we genuinely cannot calculate, because we have not yet found a second example, there might be chemistry, and in that chemistry, there might be something that replicates, something that responds to its environment, something that, over time, becomes more organized rather than less, and maybe, on some planet around that unremarkable star, something tonight cannot sleep either. It doesn't look like you. It processes information in ways you would not recognize as thinking. It has no skeleton, or has too many, or has a form of organization that maps to nothing in the catalogue of Earth life. But there is something it does, in the quiet of its night, that corresponds to what you are doing now. It is oriented toward the sky. It is aware of the darkness beyond its world. It is feeling something that functions like wonder, or longing, or the particular quality of consciousness that occurs when a mind reaches the edge of what it knows and keeps looking anyway. It does not know you exist. It has no idea that 300 or 1,000 or 1,000,000 light years away, another mind is doing the same thing, looking outward from a small warm world into the same darkness, with the same feeling of almost but not quite reaching, and yet both of you, on opposite sides of an uncrossable distance, are doing the most human thing there is, even though only one of you is human, wondering, persistently and quietly in the dark. That shared wondering is not nothing. In a universe this large and this silent, it might be everything. There are stars that deserve to be named tonight, not as data points, but as destinations, places that carry real weight in the search for something other than ourselves. Tau Ceti is 12 light-years away, a star similar enough to our Sun that it has been a target of radio searches since the earliest days of SETI. It has at least 4 planets, possibly more, and some of them orbit within the habitable zone. We have not found life there, but we have also barely begun to look, and 12 light-years, on the cosmic scale, is practically the house next door. Kepler 452b is sometimes called Earth's older cousin. It is a rocky planet slightly larger than ours, orbiting a star slightly older than our Sun, at a distance that puts it within the habitable zone, with a year of 385 days. It is about 1400 light-years away, which means the light we use to study it left during the early medieval period. We do not know what is on its surface. We know its size, its orbit, its star. Everything else is silence. And then there is TRAPPIST-1, which may be the most extraordinary nearby system we have found. 40 light-years away, orbiting a small red dwarf star, are 7 rocky planets. 3 of them are in the habitable zone. They're so close together that from the surface of one, you could see the others clearly, large and detailed in the sky, like moons that are actually worlds. None of us will go to any of these places, not in any time frame that connects to a single human life, or to a lineage we can trace. We will not set foot on a TRAPPIST-1 planet, or stand under the sky of Kepler 452b, or watch the sun of Tau Ceti rise over a horizon we have made our own. But we named them. We measured them across impossible distances, using instruments of extraordinary delicacy, and we worked out their sizes and orbits and the temperatures on their surfaces from photons that crossed light years to reach our detectors. We know they exist. That act of knowing, from here, from this distance, using nothing but light and mathematics, is its own kind of arrival, and tonight they are part of the sky you're sleeping under, whether you can see them or not. The night has a particular quality of mind that daytime doesn't offer, not a lesser quality, a different one. The linear sharpness that serves us well in the practical hours softens. The brain's insistence on sequence and resolution eases. Things that seemed separate begin to touch at their edges. Psychologists and philosophers have a name for the specific state that lies at the border between waking and sleep. It is called hypnagogia, from the Greek for sleep and guide. It is the threshold, the passage, the in-between. In this state, images can arise that feel as vivid as memory but belong to no specific experience. Connections form between ideas that the waking mind would never make. Associations that bypass logic and go directly to something older and more spatial. Many of the most striking creative insights in recorded history have arrived in hypnagogic states. Edison is said to have deliberately cultivated it, sitting in a chair with ball bearings in his hands, drifting towards sleep, catching ideas in the moment before the ball bearings fell. The ideas that live at the border, it turns out, are sometimes the ones that change things. You may be in that state now, or approaching it. The words coming in, mixing with images, the coherence of the argument loosening into something more like texture. This is the right place to hold the questions we've been asking, not the place to solve them, because they may not be solvable, but the place to inhabit them, to let them be the landscape rather than the problem, to allow the question of whether we are alone, whether the universe has room in it for minds other than ours, whether the silence we hear is absence or just distance, to exist as a feeling rather than a task. The speed of light, which we began the night treating as a frustrating barrier, has started to feel like something else, a feature rather than a flaw, a way that the universe gives every corner of itself time to develop without being interrupted, a slowness that is actually a kind of generosity. What is nearby has had time to become familiar. What is far away has had time to become itself, separately, without interference from us, and without us being subject to interference from it. The distance is not only loss, it is also protection, also privacy, also the time to become something worth meeting, and you are very near to sleep. Think for a moment about photons, not as abstractions, but as the actual things they are. A photon is a quantum of light, a particle with no mass, no charge, and no rest frame, meaning it does not experience time the way massive objects do. It is created at a source, travels at 300,000 kilometers per second regardless of the speed of whatever emitted it, and is absorbed when it meets something that can absorb it. That last part is the strange one. For a photon, because it travels at the speed of light, time dilation becomes total. Time dilation is a real physical effect described by special relativity. The faster you move, the more slowly your clock runs relative to a stationary observer. At everyday speeds, this effect is negligible. At significant fractions of the speed of light, it becomes measurable. And at the speed of light itself, for a massless particle, the effect is complete. From the photon's perspective, if we can even speak meaningfully of a photon having a perspective, no time passes between its emission and its absorption. It is created, and then, in the same instant, it is destroyed. The billion-year journey across the cosmos is, to the photon, instantaneous. The distance collapses entirely. Every photon that reaches your eyes tonight, whether from the lamp across the room or from a galaxy 2 billion light-years away, experienced its journey as a single zero-duration event. There was no travel from its frame of reference. There was only creation and contact. This is deeply strange, and I do not think it becomes less strange the more you hold it. It is one of those facts about the universe that the mind can learn and accept intellectually, while still being unable to fully absorb. But here is what it offers tonight. You're slowing down in a way that photons never do. You're made of mass, and mass carries time, and time is catching up with you in the comfortable way it does when the body finally stops resisting the end of the day. The thoughts are getting further apart. The gaps between them are widening, and in those widening gaps something quieter and older is beginning to fill the space. Not sleep yet, not quite, but the approach of it. The gentle withdrawal of all the effort that waking requires. Settle. You're allowed to be still now. There are questions that do not need answering, questions that serve their purpose simply by being held. Open, in the mind. Questions that change the quality of your attention without requiring resolution. What would a civilization with a million-year head start actually look like if we encountered it? Not what would their technology look like, but what would they look like? What would their goals be? What would matter to them? Would they still be recognizably pursuing anything that resembles survival, or growth, or meaning? Or would a million years of development have transformed purpose itself into something our minds can't pass? Is it possible that something we would genuinely call intelligence could exist in a form so unlike ours that we would never recognize it? Our definition of intelligence is, almost inevitably, built around what we ourselves are. Brains, neurons, pattern recognition applied to sensory input, sequential memory, goal-directed behavior. But there are processes in the universe that exhibit something like all of those things in distributed, non-biological, non-centralized ways. The web of dark matter that structures the distribution of galaxies, the feedback loops of stellar formation and supernova that regulate the chemistry of entire spiral arms, the quantum coherence effects in certain biological systems that we're only beginning to understand. What if mind, at scales and in substrates we have never considered, is more common than life? What if what we call consciousness is a specific, local, biological instantiation of something that the universe does naturally at many scales, in many materials, in many configurations that we lack the instruments to recognize? This is not a claim, it is a question. One of those questions that opens rather than closes, that creates space rather than filling it. The silence of the cosmos may be silence only on the frequency we have chosen to listen on. The universe may be full of a conversation we do not yet know how to hear, in a medium we have not yet learned to read, between minds so different from ours that the word mind barely applies. Let that possibility rest in the space that your thinking has cleared. There is nothing to do with it. It requires no action, only holding. There is something happening to the universe right now, on the largest scales, that deserves a place in the quiet of tonight. The universe is not static. It is not even simply expanding, which we have known since the 1920s. Since the late 1990s, we have known that the expansion is accelerating. Something, which physicists call dark energy for lack of a better understanding, is pushing space apart at an ever-increasing rate. The consequence of this, played out over long enough timescales, is that the light from distant galaxies is losing the race against the expansion of the space between us. Galaxies beyond a certain distance are already moving away from us faster than light can cross the growing gap. Not because they are moving through space faster than light, but because the space between us is growing faster than light can traverse it. This means that right now, at this moment, there are galaxies we will never see. Not because they haven't had time to reach us, but because the light they are sending will never, under any circumstances, bridge the expanding distance between us. They are already beyond our cosmic horizon, and that horizon is contracting in a relative sense, as more galaxies cross it with each passing billion years. We live in a particular window of cosmic history, the window during which most of the observable universe is still observable. In 10 billion years, perhaps earlier, the Milky Way and its local group of gravitationally bound neighbours will appear to be alone in an otherwise dark universe. Every other galaxy, every other cluster, will have accelerated beyond the horizon. The evidence that anything else existed will be gone. Future astronomers, if any exist, will look at an apparently empty universe and have no way to know it was once full. The clues will have been carried away by the expansion of space itself. We are alive in the era of abundance. The universe is still showing us almost everything it has. 93 billion light-years of cosmic history, arrayed around us like the pages of a book still open, still readable, still full of questions. Tonight is part of that. You, here, in this specific window in the life of the cosmos, looking or having looked, wondering or having wondered. The window will not be open like this forever. The breathing has changed. You may not have noticed, but it has. It is slower now, less deliberate, moving on its own, the way breathing does when the part of the mind that monitors effort has started to let go. The chest rises and falls with a regularity that doesn't require your attention, and your attention, freed from that task, is beginning to drift. There is nothing wrong with this. It is exactly right. The body knows what the night requires. You've been holding large things. The size of the universe, the speed of light, the silence of the galaxy, the improbability of us, the strange beauty of our smallness. These are not light things. They require a kind of internal effort, a reaching, a sustained willingness to feel the vertigo of scale rather than turning away from it. And now the reaching can stop. The ideas do not need to be organized, or memorized, or kept in order. They have already done their work simply by moving through you. Understanding is not always something you construct deliberately in the moment. Sometimes it is something that settles, overnight, in the process of sleep itself. The brain does not stop working when you fall asleep. It consolidates, connects, integrates. Things that seem separate get drawn together. Questions that had no shape acquire one. Insights that eluded waking logic arrive in the morning as if they were obvious, because somewhere in the night, The mind found a way to fit the pieces that was invisible to the conscious effort. So everything you have held tonight, the distances, the paradoxes, the imagined civilizations, the photons without clocks, the expanding horizon, the stardust, the silence, it is not going to be lost. It is going to be processed. It is going in somewhere, and something will come of it. Even if that something is only a slightly different quality of awe when you next look at the sky. The universe is already continuing without your supervision. The stars are turning, the galaxies are drifting, the photons are crossing the distances in their zero-duration eternities, and none of it requires you to watch. You can put it down. Let it keep going without you. It will still. Be there when you wake. Physicists have thought carefully about how the universe ends, not as speculation, but as the logical consequence of following the laws of physics to their final conclusions, across timescales so enormous that they make our current universe seem like an opening chapter. The scenario most consistent with current cosmology is called the heat death. Not dramatic in the explosive sense, but absolute in its quiet inevitability. In this picture, the universe continues to expand, driven by dark energy for billions, then trillions, then incomprehensible spans of years. Stars continue to burn for a while, but stellar formation slows as the gas that feeds it is used up or dispersed by the expansion. Over trillions of years, the last stars go out, not in explosions, but simply in the long cooling of objects that have exhausted everything. What remains, for a time, are stellar remnants, white dwarfs cooling to black dwarfs, too dim to see, neutron stars spinning down, and black holes, absorbing whatever drifts within their gravitational reach, growing, persisting, outlasting everything else. But even black holes are not eternal. Stephen Hawking showed mathematically that black holes emit a very slow radiation, losing mass so gradually that it would take incomprehensibly long times, longer than the current age of the universe raised to enormous powers, to evaporate completely. Eventually, the last black hole radiates away the last of its mass, and what remains is a universe in maximum entropy, perfectly uniform. No temperature gradients left to drive any process, no information gradients left to sustain any structure, a universe at rest, from which nothing further can happen, or distinguish itself, or become. This is not a tragedy, it is physics, and there is something in the contemplation of it that is almost peaceful, in the way that very large and very slow things can be peaceful. We are a long way from that end. The universe is young, the stars are still burning, life is still possible, intelligence is still reaching. We are the part of the universe that is organized, that is warm, that is asking questions. We are the local exception to the trend toward disorder, the temporary flame that burns while the fuel lasts. And tonight, the flame is resting. The silence has texture now. This is the silence that comes after thinking, not the silence before it. It has weight and warmth. Like a blanket that was cold when you first pulled it over you and is now the same temperature as the body beneath it. Outside, the universe continues with complete indifference and complete consistency. The stars are where they were. The speed of light has not changed. The galaxies at the edge of the observable universe are still receding, and the expansion is still accelerating, and the 93 billion light-year bubble is still expanding at a rate that will slowly swallow its own edges into darkness. None of this requires anything from you. The universe does not pause when you stop watching it. It doesn't need to be observed in order to proceed. Your attention, which has been so generously given tonight, is not a requirement for the cosmos to continue. It is a gift you gave to something that was already there, and gifts, given freely, can be taken back. You can take your attention back now. from the galaxy, from the paradoxes, from the questions that have no answers yet, from the imagined civilizations and the unmanned probes and the signals that may or may not be travelling toward us through the dark. You can let it all continue without the pressure of being watched. The body has been very patient. It has held itself in the position required for listening, and now it is ready for something different. The muscles are asking gently, not demanding, simply asking to stop holding anything at all, to release every small contraction that waking requires, to lie flat and still and undirected. The mind is very near the edge where thought becomes image, where image becomes sensation, where sensation becomes the simple fact of being, without content, without narrative, without the obligation to hold anything in particular. You're safe here. You're on a planet with enough gravity to hold you, spinning at exactly the right speed, warmed by a star at exactly the right distance. The same star whose light takes 8 minutes to arrive, and which may, for all you know, have just slightly changed. A small flare, a subtle brightening, news that will not arrive for 8 minutes more. By then, you will be asleep. There is something worth noticing before the night is entirely gone. You're on a planet at the edge of a spiral arm of an average-sized galaxy. Not at the centre, not in the dense and dangerous inner regions where stellar explosions and gravitational chaos would have made complex life improbable. Not at the extreme edges where the galaxy's structure fades into sparse intergalactic gas. In the middle outskirts, where things are stable, where stars have the right metallicity, where the conditions for a solar system like ours were actually achievable. This positioning may not be an accident. Astrobiologists have proposed what they call the galactic habitable zone, a region of the Milky Way where the conditions for complex life are most favourable. Our solar system sits comfortably within it. We did not choose to be here. No one did. The accidents of stellar formation and orbital mechanics placed us in a location that, it turns out, has some of the best real estate in the galaxy for producing and sustaining life. And from here, from this particular vantage point, the sky is as accessible as it will ever be for us. We can see out in every direction. We can observe galaxies across billions of light years. We can measure the temperature of the early universe. We can catch gravitational waves from events 1 billion years in the past. We are cosmically well placed. The universe has 4 billion years of biological history on this planet, and several hundred years of science. And right now it has produced minds that are starting, very tentatively, to understand the machine that produced them. Starting to read the equations that describe why there is something rather than nothing. Starting to ask questions that will take millennia to answer, if they can be answered at all. And on this night, one of those minds is lying still, in the dark, feeling the weight of how small and how extraordinary the situation is. Not pretending the smallness away, not inflating the extraordinary into fantasy, just holding both. Small enough to be humbled, large enough to notice, both at once, which is the most honest position available. Let it be the last clear thought. Let it drift. The universe makes no sound. This is worth sitting with for a moment, in the particular silence of this hour. Sound requires a medium. It requires molecules that can compress and rarefy, that can pass the disturbance of a vibration from one to the next in a chain. In the vacuum of space, there is no such chain. The distance between molecules is so vast that no vibration propagates. No sound crosses interstellar space. The sun is an object of unimaginable violence. Perpetual nuclear fusion, magnetic field lines snapping and reconnecting with the energy of billions of nuclear weapons, solar flares ejecting billion-ton clouds of plasma at millions of kilometers per hour, a surface convulsing with cells of rising and falling gas larger than continents, constantly, without interruption, for 4.5 billion years. We hear none of it. The Earth is 8 light minutes away, and even if it were much closer, there is nothing between the sun and us that sound could travel through. The violence of the universe is wrapped in perfect silence from our perspective, and we're aware of it only through the light it sends and the instruments we have built to interpret that light. In 2015, those instruments reached a new level of sensitivity. The LIGO detectors, 2 enormous facilities in the United States, each consisting of 4-kilometre-long perpendicular tunnels with mirrors at each end, achieved the precision necessary to detect a signal that physicists had been theorizing about for decades. 2 black holes, each many times the mass of our Sun, had been spiraling toward each other billions of light years away. In the final fraction of a second before they merged, they released more energy than all the stars in the observable universe combined, in the form of gravitational waves, ripples in the fabric of space-time itself. Those ripples travelled at the speed of light across billions of light years, arriving at Earth with an amplitude smaller than 1,000th the width of a proton. And LIGO heard them. We are learning to listen in frequencies we never knew existed. The universe is speaking in a language older than light, and we are just beginning to read it. One detection at a time, one dream at a time. The thoughts are coming more slowly now. There is more space between them than there was an hour ago, and in that space something quieter is taking hold. Not emptiness, something more like the state that holds the potential for dream without yet committing to any particular image. This is the passage, the approach, the architecture of consciousness rearranging itself for a different kind of operation. Let's trace a path back to the local, from the cosmic scale where we have been for most of the night, down through the orders of magnitude to here, from the observable universe, 93 billion light-years across, down to the Laniakea supercluster, 500 million light-years, our galactic neighbourhood on the larger scales, down to the Virgo cluster, which Laniakea is falling toward, 65 million light-years out, down to the local group, the few dozen galaxies gravitationally bound to ours, 2.5 million light-years, down to the Milky Way, 100,000 light-years, and our position in it, 26,000 light-years from the centre, down to the solar system, a few light-hours across, down to the Earth, about 40,000 kilometres in circumference, down to the country, the city, the street, the building, the room, down to the breath, down to the single moment of this inhale, this exhale, this temperature of the air against the skin, this weight of the body against the surface beneath it. Every scale has its own beauty. The cosmic has the beauty of incomprehensible size and age. The human has the beauty of specificity, of this particular body, this particular night, this particular accumulated experience of a single life looking outward and finding it worth looking at. The atoms of your body were forged in stellar interiors, the carbon, the oxygen, the iron in your blood, all of it synthesized in stars that ended before your solar system began. You're a local organization of material that the universe spent billions of years producing in the cores of dying stars. You're stardust, thinking about the stars it came from. That thought is almost ready to dissolve. Let it. Something has shifted in you during the course of this night, and it is worth naming even as it is happening, before it becomes too subtle to articulate. When this began, the speed of a light felt like a barrier, a frustration, a rule that the universe imposed on ambition, keeping everything separated, keeping aliens away, keeping us earthbound while the rest of the cosmos proceeded without us. Now it feels different, not smaller, not less absolute, just differently weighted. The speed of light is not only what prevents arrival, It is also what makes the sky a history, what gives every star a story that took light years to write. What means that the photons arriving at your eyes tonight have been in transit for lengths of time that dwarf everything human, carrying information about fires that burned before your planet cooled. Without the finite speed of light, the universe would be immediate in ways that might not be survivable. Every event everywhere, instant, no horizon, no protected distance, no time to develop in privacy, no local evolution undisturbed by the rest of the cosmos. The slowness of light, paradoxically, may be part of why anything like us exists at all, and the silence that comes with it, the great quiet Fermi noticed, the absence of a galactic civilization that has filled every available niche. That silence may be protecting us too, giving each pocket of life the room to become something before being encountered, absorbed, redirected. The universe is slow, and in its slowness, it is generous. You have stopped gripping the ideas now. They are no longer objects you're holding, more like weather, something that moves through rather than something you carry. The questions are still there. They have not gone, but they are no longer demanding anything from you tonight. They will be there in the morning. The galaxy will not have answered them by then. The Fermi paradox will still be open. The wormholes will still be theoretical. The signals we have not received will still be absent, but you will be rested. And a rested mind is better at wondering than a tired one. Sleep is not a withdrawal from the universe. It is maintenance of the instrument you use to perceive it. The last thought before sleep is different from the thoughts that came before it. Not less, different. It has less edge, more warmth. It is not trying to get anywhere, not building toward anything, not holding the thread of an argument or waiting for a question to resolve. It is just there, briefly, before becoming something else entirely. Maybe the last thought is this: somewhere in the universe tonight, something is awake, not necessarily biological, not necessarily local, but something that corresponds, however loosely, to the state you have been in for the last hour or so, a state of attention directed outward, of awareness that the local, the immediate, the visible is only a small part of what exists. Something, on the other side of distances we cannot cross, is oriented toward the dark and finding it worth orienting toward. It does not know you exist. Your planet is below the resolution of anything it can detect. Your civilization is invisible at the distance and on the timescale that separates you. Your name, your history, your experience of this particular night are inaccessible to it in every possible sense. And yet it is doing something that rhymes with what you are doing. Wondering, quietly, in the dark. This is what the speed of light cannot prevent, not the contact, not the physical presence, not the signal or the ship or the conversation. All of that it prevents completely and without exception. But the gesture, the orientation, the act of a mind turning toward what it does not understand and remaining turned, this is not transmitted through space. It does not require a medium. It requires only that intelligence, wherever it arises, tends to behave this way, to look outward, to ask. If that is true, then the universe is not as empty as the silence suggests. It is full, in every direction, of beings in the posture you're in right now, looking up, and the distance between you is not only separation, it is also the space that made you separately, that gave each mind its own development, its own path to the question. The distance is what made you what you are. Now let go of even that. You have travelled a long way tonight. From a question asked in the opening seconds of darkness, where are you? What time is it? What does the sky look like outside your window? All the way to the edges of what physics and imagination can reach together. From the speed of light as a number to the speed of light as a feature of reality with consequences that reshape everything. From the silence of the galaxy as a frustration to the silence of the galaxy as something more complicated, more interesting, and more worth sitting with in the quiet of a late night. If you are still here, if your mind stayed with this voice across all of that distance, then something in you chose to keep choosing wonder over sleep, kept letting the ideas in even when they became strange or large or without resolution. That is not nothing. That is actually one of the most distinctly human things there is. Before the night finally closes over you entirely, one small thing. If something in this journey moved something in you, if you felt the vertigo of scale, or the quiet of the cosmic perspective, or the strange comfort of being made of stardust and knowing it, then share it. Leave a like, not as a metric, but as a signal to someone else who might be lying awake somewhere wondering the same things, that this kind of quiet is worth finding. Subscribe to Sleep Space if tonight was the kind of company you want to keep. There is more universe to explore before sleep, more questions with no answers, more distances to measure in the dark, and leave a comment. This is the one we actually read most carefully. Tell us where you are listening from. Not just the city or the country, though those too, but the texture of it. Is it raining where you are? Is the window open? Is someone else asleep nearby? Are you in a place you have always lived or somewhere you only recently arrived? Every listener is a point in space. Every comment is a signal crossing a small and manageable distance, from you to us, arriving almost instantly, light speed over fiber, which means it is the fastest communication the universe permits, and it is available to you. Use it. We are here. We hear you. The universe is large and old and mostly silent, but in this small corner of it, right now, we are glad you are on it. Good night. Sleep well. The questions will keep until morning.